So right after lunch, best time for any presentation. So Anax Power. My name is Michael Longo, and my company generates clean power from natural gas without any combustion. And the way we do that is with a technology that I'm sure some of you in here are familiar with. It's called the natural gas Turboexpander generator. And what I'm going to do over the next couple of minutes is three things. First, I'm going to give a brief overview of how Turboexpander technology works. Second, I'm going to talk a little bit about what makes our technology different from what's been tried in the Turboexpander market in the past. And third, I'm going to go into the customer value proposition a little bit. And then finally, we'll have some time again for questions if there are any. So to start giving a brief overview of how Turboexpander technology works, I'm going to take a look at something we should all recognize, traditional pressure regulating valve, taking gas from the transmission pressure level and getting it all the way down to the appropriate level for the end user. Right? And what we love about this instrument is that it does a really good job at what it's supposed to do. Right? So it's safe, it's reliable, but it's not always efficient. Right? And so what we did in the design of our Turboexpander technology is we asked ourselves, how can we maintain the safety and reliability of your traditional pressure regulating valve, while at the same time removing the inefficiency associated with energy loss in the natural gas regulating process? And where we landed was with this, the Anax Turboexpander. And what you're looking at on this screen is our first generation 400 kW unit, which each one of these units generates 400 kW, and you can install as many of these in parallel as the mass flow and the pressure requirements come in. Now, what's great about this is it reduces natural gas pressure and generates clean distributed power. And what's even better than that is that it actually increases safety redundancy by operating in parallel with the existing pressure regulated valves. So if anything goes wrong with the machine or the electrical load or anything like that, gas bypasses through the pressure regulating valves and is delivered to the end customer in exactly the same way as it is delivered today. Okay? So it increases safety redundancy. Second, you're generating 100% clean energy from waste, right? And what we've heard time and time again from our customers is that the natural gas industry is really interested in some good environmental wins, right? So that's something that we believe this technology represents. Now, you're generating the power from the pressure and the flow of the gas moving through the pipeline. We also can integrate with waste heat systems or the existing heating at the pressure regulating station, depending on what makes the most sense for each specific project. And then finally, the best part from a customer value proposition standpoint is it has an outstanding ROI and has the ability to operate with volatile natural gas conditions, right? And as we present this technology to different groups, what we hear is that it makes a lot of sense, there seems to be a need for it, but the question we inevitably get is, well, why hasn't this been tried before? And the short answer is it actually has, right? So if you go to any large industrial technology company, a Baker Hughes, a Rotoflow, Cryostar, any of those companies, they have this product listed on their website. But what you very quickly realize with just a little bit of research is that even though it's listed on their website, there's none actually in operation in the field. And the reason for that is because those large companies, what they did is they took Turboexpander technology in the space where it's traditionally operated, in the cryogenic space. And in that space, the gas conditions are quite stable. And they took that technology and they tried to apply it to this natural gas transmission distribution market with natural gas conditions that can vary on a minute-by-minute basis. And so what happened when they took this technology that was designed for very stable conditions and put it in this volatile environment, well, you had unreliable performance, right? No surprise there. What makes Anax different is that we started with those customer conditions. We took customer data and said, how do we design a machine that's effective and works beautifully with the conditions that we are given? All right? And because of that, we've been able to overcome this unreliable performance standpoint that's plagued Turboexpanders and their adoption in this market in the past. Second is, and we verified that in 2017, we worked with the Gas Technology Institute on a performance and safety test, performed beautifully, and we're in the process of commercializing right now. Second is this scalable. So the other Turboexpanders haven't been scalable because there's so many different pressure regulating stations with different flow rates, different temperatures, different locations. Every one of these systems had to be custom engineered in order to meet the parameters of the specific site. Right? That carries with it a ton of really, really expensive, prohibitively high one-time engineering expenses. Anax is a little different because we are a modular plug-and-play solution. So you see here that we have, not only is this plug-and-play, this is actually in Scotland, plugs right into an existing T connection, but it also sits on a skid that's easy to transport, easy to install, and easy to operate, and thus avoids a lot of those one-time prohibitively high engineering expenses, which make other Turboexpanders just too expensive from an ROI standpoint to justify any type of investment. What Anax did when we were designing our technology is we went to our customers first and we said, what would have to be true for this to make this a no-brainer capital investment decision for you? And they told us what had to be true, and we designed our machine to be cost-effective based on those numbers, and we've surpassed our targets to date over the past 18 months. So that's a little bit on what differentiates Anax. The last thing I'm going to talk about here is our customers, who they are, what they look like, and how they can benefit. Okay? So customer value proposition, I'm going to talk about the three main types of customers that we have. First, you have your natural gas generating facilities, the 568 baseload natural gas plants in the US. They can improve the efficiency by incorporating our technology. Second, which is more applicable to everyone in this room, are your thousands of city gate and gas compression stations. Now, what's really interesting about this is that up until a couple of weeks ago, we were only focused on the city gate stations, where the pressure was actually coming down. But what we heard from our customers is that, no, this would actually go really well with the compression stations too. Anybody have any idea why? Fuel, well, what they said was that they were going to run a line from the compressed end, loop it back through our machine, and then recompress it, take the power and use that to power the electrical load at the remote compression station. So that was something we didn't even think about that has good applicability in the transmission market. All right? And then third, what we have here are over 1,000 large industrial users of both natural gas and electricity. Right? These are your glass factories, your steel mills, oil refineries that can use this to offset their parasitic load in their plants, and the savings drops right down to the bottom line in the form of millions of dollars per year. Okay? And the way that these companies benefit, just quickly, improve plant efficiency, reliable distributed power generation, it's clean energy, and because it's clean energy, there's lucrative, very lucrative state, federal, and local renewability incentives. And then finally, it has an excellent market-leading ROI that we designed with our customers. Okay? So that's everything I had, and then